So now I want to investigate the graphs of polynomials a little bit more. So if you remember all the characteristics we know about polynomials, maxes and minimums, so they're where it changes from increasing to decreasing, absolute maxes and minimums, they're the lowest and highest point, x-intercepts where it crosses the x-axis, y-intercepts where it crosses the y-axis. So these other things might be a little bit new in the polynomials. A turning point is a place where it changes direction from increasing to decreasing or decreasing to increasing. That's kind of like a max or min, right? So when you think about a turning point, these occur at the max and mins. And the end behavior, we talked about this in a previous video. So we look at the degree and the leading coefficient. If the degree is even, they go in the same direction. So these are both going up or both going down. If the degree is odd, they go in the opposite direction. One goes up, one goes down. If the leading coefficient is positive, then the right-hand side always goes up. So you can use that to describe the end behavior. Remember, we write it as x goes to infinity, y goes to infinity, or it rises on the right. And as x goes to negative infinity, y goes to negative infinity, it falls on the left. So what we want to do is sort of use all those properties and answer questions about a polynomial. So here's my polynomial, negative x to the fourth plus x cubed plus 2x squared. So we're going to start with just some basic questions. What's the degree? The degree is the highest exponent, so degree 4. The leading coefficient, so in this case the leading term is that negative x to the fourth. So the leading coefficient is going to be negative 1. So what can I answer from the leading coefficient? Well, that tells me the end behavior. And the degree also helps with that. So this has even degree. So the ends go the same direction. And the leading coefficient is negative. So the right-hand side goes down, and the left-hand side has to do the same thing, also going to go down. So as x goes to infinity, f of x goes to negative infinity on both sides. So it falls on the left and on the right. That's my end behavior. For these other things, I'm going to go ahead and plug it into my calculator and see about the end behavior, see about all these other properties. So negative x to the fourth plus x cubed plus 2x squared. Negative x to the fourth, whoops. Plus x cubed plus x squared. Negative x to the fourth plus x cubed plus 2x squared plus 2x squared. Okay, so here's my graph. So I'm going to look at all the important points about this graph. What I see is I have three turning points, excuse me. I have two maximums and a minimum. I have 3 x-intercepts. One of them has a multiplicity of 2. Right there at 0, it has a multiplicity of 2 because it's sort of bouncing off the x-axis. And I have 1 y-intercept. So let's draw this graph in our paper over here. So the x-intercepts were at negative 1, 0, and positive 2. So negative 1, 0, and positive 2. Negative 1, 0, positive 2. Okay. This came down like this. This went up, came down, went up, came down, kind of like that. These 3 were my turning points, the maxes and mins. If I look at this graph, the domain is all real numbers. It goes forever to the left, forever to the right. The range goes from bottom, negative infinity, to the top, whatever this point is here. So let's go write down those tops and bottoms. So negative 0.693 and 3.397 and 1.443 and 2.833. 1.443 comma 2.833 and negative 0.697 comma 0.357, I think it was 0.397 0.693 and 397. Okay, so my x-intercepts were at -1, 0, and 2. My y-intercepts were at 0. The range, remember the top, this is the topmost y value that I reach in that point right there. So from -infinity to 2.833. It includes that point, so we're going to put a bracket there. This graph is increasing here, and then decreasing, and then increasing, and then decreasing. So when we do intervals of increase and decrease, and we use x values, so it's increasing from -infinity to -0.693, and from 0 to 1.443. It's decreasing from -0.693 to 0, and from 1.443 to infinity. It's never constant. I have two local maximums at x equals -0.693 and x equals 1.443. The global maximum is at that 1.443, 2.833. I have one relative minimum at the 0, 0. The global minimum, I don't have any because this graph goes down, down, down forever. So there's no minimum of this graph. Okay, and then the zeros and the multiplicities. Remember, I had three zeros. X equals -1. X equals 0, and x equals 2. At -1, it crossed. At 2, it crossed. And at 0, it bounced. So this means that it has an odd multiplicity. We could say multiplicity 1. This means it has even multiplicity. We could say 2. And this, again, crossing means odd multiplicity 1. Another way to think about this is we maybe could have factored this, right? So if I factor out a -x squared, I'm left with x squared minus x minus 2. And now I can factor this guy. I need two numbers that multiply to make -2 and add to make 1. So -2 and +1. So if you see this 0, x squared gives me x equals 0, has multiplicity 2. X equals 2 has no exponent, so that's multiplicity 1. And x equals -1, again, has no exponent, so that's multiplicity 1. So I went ahead and found all those properties about this polynomial function and use the graphing calculator. That's going to be very helpful.